Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, class. Today we cover topic 3, computer programs and programming language. So the lesson outcome for this topic, first is you must be able to give me the overview of computer program and the programming language. Next is to explain the programming language paradigms. Okay, there are 4 main paradigms that will be covered here. And then the programming application domains, the 5 application domains. Okay, these are the things that you must be able to explain, to list, to differentiate at the end of the lesson. So let's see overview of computer program and programming language. What is a computer program? We already said this too many times. A computer program is a set of instructions that the computer needs to follow to process the data into information. So the for data input to become an information, you have to process using a computer program. So what will the computer program do? They will tell the computer what actions you want to the computer to perform and what are the order of those actions that should happen in. So the elements of computer program, we have input, we have processing, we have output, and then we have storage. For input, whatever data that is inserted into the computer using any input devices. Okay, example of input devices that we normally use are mouse and keyboard. Then after the data is inserted into your computer, it will be processed, so that the input will become an information. So we use the CPU to process your input. And then after the input is processed, so of course you will have an output, which is the information, useful information. So the device that produce an output, example is monitor and printer. Lastly, for the storage, of course we want to store or we want to save the information. Okay, so we store the data or information for future use, either permanently or temporarily. We use hard disk and memory. So the programming language is a system of sign used to communicate a task or algorithm to a computer, causing the task to be performed. The task that is to be performed is called computation, that will follow absolutely precise and unambiguous rules. So it contains set of instructions, data and rules that are used to construct a program. So let's see, computation is any process that can be carried out by a computer. It includes all kinds of computer operations, including data manipulation, text processing, and information storage and retrieval. So the programming language must be machine readability. For it to be machine readable, it must have a simple enough structure to allow for efficient translation. Okay, because the computer need to translate what you type into something that is readable by the computer, which is a machine. So it is the machine readability is ensured by restricting the structure of programming language to context-free language. Human readability, another criteria, is it requires that a programming language provide abstraction of the action of computers that are easy to understand even by a person not completely familiar with the underlying details of the machine. So the programming language tends to resemble natural language. So therefore, human can understand even though they are not thoroughly understanding the machine language. So basically, there are 3 levels of programming languages. First one is machine language. Second one is low-level language. And then the third one is high-level language. Machine level language consists of individual instructions that will be executed by the CPU one at a time. It uses binary code since machine and computer only knows the concept of on or off, either 1 or 0. And then we have low level language. Here we have the language called assembly language, designed for a specific family of processor because different processor group or family has different assembly language. It consists of symbolic instruction directly related to the machine language instruction one for one and are assembled into machine language because your machine or your computer only knows on and off. So it resembles the machine language but use a symbolic instruction that can be understood by human. And then we have high level language. Example that we use is C++ here. In UiTM, we have Java and also VB that is covered in the UiTM syllabus. And then we have actually the basic one is the C. The high-level language is designed to eliminate the technicalities of a particular computer. Statements compiled in this high-level language will generate many low-level instruction machine or the computer that only knows on and off. Okay, it means even though you are using the high-level language, okay, the language will be translated back into a machine language. So therefore, the computer can process because your computer only knows on and off. Understand? Then, okay, let's see more on the machine language. You already seen this in CSC116, I think. Okay, the representation of a computer program which is actually read and understood by the computer. That is what I mean, on and off. A program in machine code consists of a sequence of machine instructions. So the instructions are in binary code and it specifies the operation and the memory cells involved in the operation. Okay, let's say this. If these are the operation, so these are the address used for that operation. So next, the second level language is the assembly language. Remember, okay, the low level language. Low level language. Okay, it uses a symbolic representation of the machine language of a specific processor converted to machine code by an assembler. So for this language to be understood by the computer, it needs an assembler, okay, because the assembler will convert the assembly language into machine language. Usually, each line of the code produce one machine instruction. That is what it means by one-to-one correspondence. Programming in assembly language is slow and error-prone, but it is more efficient in terms of hardware performance. So this is the advantage. Okay, these two are the disadvantages of the assembly language. Okay, there are many more. Please find it using your other sources. Mnemonic representation of the instruction and data. Okay, the assembly language will use a mnemonic representation of the instruction and also of the data. Okay, let's see. This is the mnemonic instruction. Load, add, store can still be understood by human. Okay, these are the variables. For the high level language that is human readable, understood by human, okay, easily understood, the programming language will use statements consisting of English-like keywords such as for, print, if, and so on. So each statement will correspond to several machine language instructions. That is one to many. Okay, not one to one, but one to many correspondence. Much easier to program. Okay, this is the advantage. Okay, data are referenced using descriptive names. Operations can be described using familiar symbols. Okay, that's why it is easy to understand. Familiar for human. Example, cost equal to price plus tag is the mathematical expression that you use every day. So let's see the paradigms. We have four main paradigms. So first of all, what is a programming paradigm? It is a model for a class of programming language that share a common characteristic and it's different. Okay, it shares the common characteristic and also the differences. So the common programming paradigm we have imperative paradigm, we have object-oriented paradigm, we have functional paradigm and logic paradigm. So in the imperative paradigm, the sequential execution of instruction, the use of variable representing memory location, and the use of assignment to change the values of variable. For the object-oriented paradigm, it allows the programmer, that you, to write reusable code that operates in a way that mimics the behavior of objects in the real world. Okay, while the functional paradigm is based on the abstract notion of a function as studied in the lambda calculus. And lastly, the logic paradigm is both based on symbolic logic. So let's see more on the imperative paradigm. It describes how the computer should achieve solution. Okay, example of these languages are C, Pascal, Fortran, Argo 60, and COBOL. Okay, the key features: it stored memory, it has mutable variables, offers sequencing, selection, and iteration, and it uses pointers. Example, C. Okay, the most basic in the high-level language is C. INT main, similar to C++, okay, because C++ is actually the sambungan for the C language. Okay, very similar to C++. Just here, scanf. In C++ we have what? Okay, okay. The other thing is quite similar. Scanf, readf. Maybe okay, this is an assignment statement. Okay. Next, the second paradigm is object-oriented paradigm based on imperative or procedural style with added data and code abstraction and encapsulation. A revolutionary concept that changed the rules in computer program development. Okay, it is organized around objects rather than actions. Okay, data rather than logic. Example of languages that is in this paradigm are Smalltalk, C++, and Java. The key features of this paradigm is abstraction, encapsulation, inheritance, and polymorphism. So this is an example of Java program. Remember? Or you will learn this later. Okay, how to program a Java code. It is quite similar, but the syntax will be different. Okay, and it will have the concept of class. Okay, because it uses inheritance. All these things are abstraction, encapsulation, inheritance, and polymorphism. Okay, and then we have logic paradigm, which is a declarative and relational style of programming. Example of logic paradigm language is Prolog. Okay, concept is based on Horn clauses, okay, based on facts and rule known as clauses. Clauses may contain logic variables which take any value necessary to make the fact or the left side of the rule match a goal. Okay, the key features: non-mutable variables. Statements are logical predicates or assertions. Every statement can either be succeed or fails. Few explicit control construct and recursion. Okay, this is an example of prologue statement, prologue code. Speed Ford 100, speed Chevy 105, and so on. You will learn this later in 305. CSC 305. Sorry, CSC. Okay, what does it mean? You cannot understand it right now. Even though I explained, it requires a higher logic, okay, for your thinking. And then we have functional paradigm that is based on the concept of functions in mathematics. Okay, based on lambda calculus, program returns are compact. This is the advantage. The disadvantages are it runs slowly and require a lot of memory. Example of language are Haskell, ML, LISP, and Scheme. The key features: no mutable variable, everything is an expression, everything is a function, no iteration, and use recursive. The example of Scheme program, the coding, okay, define factorial and if less equal and 1. What is less equal and 1? Okay, so you will learn this later also in 305. Okay. So the domains, okay, where we use all the different programming languages. What are the domains? So let's see this one. We have Fortran, COBOL, ML, Perl, Java, C, C++, LISP, Simula. Okay, can you identify where will this programming language be used? Okay, macam kita nak masak kuih lah. Awak nak guna baking soda bila? Nak guna apa? Nak guna mixer bila? So kat mana benda-benda tu kita nak guna? Okay, different cakes requires different ingredients. So here, different languages, okay, is used for different intention, different domains. Okay, so let's see. Fortran is used in scientific computation. Okay, COBOL is used in business application. ML is used in compiler construction. Perl is used for web application. LISP is used in symbolic computation. Simula is used in user interfaces. Simulation is used in Java. And C++ and C is used in system programming. Okay, the domains. Okay, already been said before. So example of application that use Fortran is NASA and biotech. Okay, example of application that use COBOL is banking. Example of application that use LISP or Prolog for AI, artificial intelligence, is manufacturing and robotic. Okay, for the system programming, the languages, example, used in operating system, web software, example of the languages, and then is used in the internet applications. So for the scientific application, the team that developed the Fortran is the John Becker's team at IBM, okay, in 1955 until 1957. So Fortran is the short for formula and translator. So while it was designed for numerical computation, it included the control structure, the conditions and input, output. The popularity of the Fortran led to the Fortran 2 in 1958, Fortran 4 in 1962, leading to its standardization in 1966 with revised standards in 1977 and 1990. For the business application, we have COBOL. Okay. For the business application, the commercial data processing was one of the earliest commercial application of the computer. Grace Murray Hopper at Univac developed, okay, with all the other developers, developed the Flowmatic and English-like language for business application. The US Defense Department sponsored the effort to develop the COBOL. Okay, it stands for Common Business Oriented Language that was standardized in 1960, revised in 1961 and 1962, re-standardized. Okay, re-standardized. There is typo here, sorry. In 1968, 1974 and 1984. And then we have AI, artificial intelligence. It deals with emulating human-style reasoning on a computer. Okay, the application usually involves symbolic computation, where most of the symbols are names and not numbers. The most common data structure is the list, not the matrix or array, as in scientific computing, and not the record as in business computing. AI requires more flexibility than other programming domains. Okay, because macam kita bercakap lah. Okay, I kalau cakap biasa, I cakap bahasa Boer. Bukan bahasa dialek Boer. Kalau I cakap untuk orang macam you all, I cakap bahasa pasar ke. Bahasa Melayu lah, tapi maksudnya jangan difahami oleh semua negeri dalam Malaysia ni. Okay, so it requires more flexibility. So the robot that was programmed using the AI will understand what the human instruct them to do. Okay, macam kita kata lights, kita suruh dia buka lampu kan, senanglah lights. Okay, tapi kalau lah slang dia lain. Okay, macam saya cakap tadi, sebutan mua, sepatutnya mua. Okay, jom kita ke mua. Saya cakap dengan robot tu. Tapi saya cakap, jom kita pergi mua. Nampak tak? Benda tu fleksibel tau. So, dia kena banyak faham. So, that's why AI requires more flexibility. Okay. So, the first AI language was IPL, stand for International Processing Language, that was developed by RAND Corporation. Its low-level design led to its limited use. Okay, sebab design dia rendah, so kegunaan dia terhad. John McCarthy of MIT developed LIST for IBM 704 that eventually led to Scheme and Common LISP. So LISP is a recursion-oriented list processing language that facilitated game playing program. Okay, ni payah nak menyebut nama orang ni, awak je dah sendiri. MIT, okay, from MIT developed the Commit, a string processing language which was followed by the AT&T Snowball. And then Prolog was developed by the Komarov, Russell and Kowalski based on the predicate calculus and mathematical logic. System programming, okay. For the system programming, the assembly language were used for a very long time operating system programming because of its power and efficiency. Okay, we have CPL, BCPL, C and C++ were later developed for this purpose. Okay, kalau tidak sebelum ni diorang guna ni kan, lama diorang guna. Okay. Other languages for system programming included VL, I, Bliss, and extended Argol. And then lastly, we have web software. Okay. Diverse collection of language. We have markup language. Example is HTML, used for annotating a document in a manner that can be distinguished from the text. We have scripting. Example PHP, the language that enables the script to run these commands and typically include control structures such as if, then, else, and while, do. And then we have general purpose language, example Java, that can be used for a wide range of programming jobs. Okay, guys? So that is all for today and for this topic. So please prepare. We have next week you have a quiz for topic 1 until topic 3. Okay, the question will requires you to think rather than to find the answers in the internet. Okay, so please study first. You won't find the exact answer even though you search in the internet. Okay, class. So thank you. See you in next class. So don't forget, if I give you tutorial, please submit it before the due date. Alright. Thank you. Bye bye. Assalamualaikum.